Hello everyone, today we are going to start our new lesson, moles in terms of volume. When we are talking about volumes, keep in mind that here two things are being taken into consideration. One is that of liquids or solutions, and another one is gases. Why gases and solutions or liquids? Because we usually use the unit of volume for the measurement of solutions or gases. We also measure solutions through mass by taking the unit gram or weight. But usually volume is used for the measurement of solutions, okay? And gas is usually measured in volume. So first of all, we have to understand the conversion of units of volume. Okay, interconversion of units of volume. So we know that volume is measured usually in liter. Okay, and we know that 1 liter is equal to 1000 milliliter. Is that clear? In the same case, 1 liter is also equal to 1000 decimeter cube. Is that clear? So 1000 decimeter cube. 1 liter is equal to 100 centimeter cube. Sorry. So 1 decimeter cube is equal to 1 liter is equal to 1000 centimeter cube. And 1 meter cube is equal to 1 liter 1000 liter, or is equal to 1000 decimeter cube. Is that clear? So how this come out? For example, we know that we manage these values from basic unit. We know that 1 decimeter is equal to 10 centimeter. So 1 decimeter cube, the cube would be equal to 1000 centimeter cube. That's simple. Is that clear? In the same way, we know that 1 meter is equal to 10 diameter. So 1 meter cube would be equal to 1000 decimeter cube. Is that clear? So this 1 centimeter cube, sometimes also called 1 cc. Okay, so 1 decimeter cube or 1 liter is also equal to 1000 cc. Is that clear? So this is the interconversion of units of volume. Now, related to this, another unit which is usually used in this is usually pressure is also being used. Okay, we will also so pressure, we know that it is usually in chemistry. Most of the time, pressure is usually measured at 1 atmosphere. Okay, so or sometimes Pascal is used. Okay, so 1 atmosphere is equal to 1.013 into 10 raised to power 5 Pascal. Okay, sometimes it's also simply called 10 raised to power 5 Pascal. So this is the simplified unit of pressure. Now coming towards the solution, as we know that in terms of solution, so moles is equal to concentration multiplied by volume of the solution in diameter cube. Okay, this can also be written the formula as moles is equal to molarity. This is also called molarity. Okay, molarity multiplied by volume in diameter cube. So you can also find the formula of molarity. You can also find molarity of any solution or concentration of any solution to this. That is equal to moles over volume, usually taken into Demeter cube. Is that clear? Now water concentration. Concentration is the amount of solute present in solution. Is that clear? This can be defined as concentration or molarity. This is called molarity. Molarity or concentration can be defined as the amount of solute present in solution. And this formula is moles over volume. So from this perspective, we will study, or we will calculate the moles of solution. Now, for example, the question is given for you that there is sodium solution of copper sulfate. Okay, there is solution of copper sulfate. Okay, and moles are given. Moles of copper sulfate, which is equal to 0.02 moles. Okay, and the volume is given. Volume is 200 centimeter cube. Okay, so in the first step, what will you do? You have to convert the centimeter cube or whatever value is given. You have to convert that into Demeter cube. So we know that Demeter cube is larger than centimeter cube. So what will we do? We will take volume as we will divide the centimeter value, which is smaller value, by the higher, by 1000, because we know that 1 centimeter cube, 1 Demeter cube is equal to 1000 Demeter cube. Okay, so dividing 200 by 1000, we will get 2 over 1 by 1 over 5 is equal to 0.5 Demeter cube. Now we will find the molarity or concentration of the solution. Which is equal to, we know that mole over volume. So moles are given, that is 0.02 divided by 0.5. So if you divide this value, 0.02 divided by 0.5, it comes out to be 0.4. 0.04 mole per Demeter cube. The value of concentration is mole per Demeter cube. Keep in mind, mole per Demeter cube. So these equations in your workbook, question number 1 on page 4, exercise 1.5 on page 4, you need to calculate moles, and volume is given and molarity is given. So we know that moles of HCl would be equal to molarity multiplied by volume, and here molarity is 0.4. Now the volume is already given in Demeter cube. No need to convert them into other unit. So 1.5 it will get multiplied. So 1.5 0.6 moles. Okay, the same way in the second question, moles are given. Well, you have to find the moles. Weight are given and volume is given centimeter cube, and concentration you have to find. So first of all, you have to find the moles, because we are in the end we have to find the concentration. So for finding the moles, the volume of sodium hydroxide, so we know that we have to find the moles of sodium hydroxide is equal to weight over its molar mass of sodium hydroxide. Weight is given 5.4 divided by mass of sodium is 23, that of oxygen is 16, and hydrogen is 1. 16 plus 1, 17, 17 plus 23 is equal to 40. So 40. So So moles would be 5.4 divided by 40, comes out to be 0.135 moles. Is that clear? So in the next step, as according to the requirement of the question, we have to find the concentration, and it is equal to moles over volume in diameter cube. But here volume is given in centimeter cube. So what we will do, we have to convert volume into 150. We will divide 150 over 1000. Okay, and it comes out to be 150. It comes out to be 0.15 centimeter cube, diameter cube, sorry. So moles are 0.135 divided by 0.15. So concentration would be 0.135 divided by 0.15. It comes out to be 0.9 moles per diameter cube. This is concentration of sodium hydroxide in water. In the next question, the same question, solution of ethanoic acid containing 12 gram of ethanoic acid and 250 centimeter cube of solution. So in the same case, we have to first find the moles of ethanoic acid, CH3CO2H, and weights are given, that is 12 divided by its molar mass. Molar mass, there are how many carbon? 2 carbon atoms. Mass of carbon is 12, plus how many oxygen atom? 2 oxygen atoms. So 2, and mass of oxygen is 16, and 4 hydrogen, 4 multiplied by 1, 4. So 12 will get multiplied with all these value. 12 multiplied by 2 plus 16 multiplied by 2 plus 4, it comes out to be 60. 12 divided by 60, it is equal to 0.2 moles. So volume is also given in centimeter cube. We have to convert them into diameter cube. For that we have to divide with 1000. Okay, so it comes out to be 0.25 diameter cube. Now we will find the concentration, sometimes also called molarity. This is equal to which is equal to moles over volume. 0.2 moles divided by 0.25. So 2 divided by 0.25 comes out to be 0.8 moles per diameter cube. So this is how you can convert, you can find volume, molarity and moles from this equation. The next important concept in calculating the moles of the solution, the next concept that comes in our mind is related that of titration. What is titration? Titration is used to determine the amount of substance present in a solution of unknown concentration. Whenever we want to find the concentration, whenever we want to find the unknown concentration, okay, the unknown concentration of a solution through known concentration. This is called titration. Okay, and keep in mind that usually we do titration of that of acids and bases. Is that clear? Usually titration is being done for acids and bases. If you want to find the concentration of a base, we titrate it against acids, and whenever we want to find the concentration of acids, we do titration of this acid with the base. Okay, in this way we also do titration of various salts. Okay, various salts are also being included in this list. So keep in mind that this titration is also in this, while calculating titration we have to apply the mole concept as well. Okay, why? Because we have to apply mole concept in order to find the unknown concentration. Okay, and we will do a question related to this, for that how we apply the mole concept during any titration. For example, let's suppose this is acid A react with the base B, and what happened that the following products are formed. Salt, this is salt, and this is water. Whenever acid and base, keep in mind that whenever acid react with a base, always salt and water is formed. Okay, salt and water is the product whenever acid and base is react, and these are their stoichiometric coefficient. Okay, so if for example here concentration is given, is that clear? Mole concentration is given and volume is given also. Okay, concentration is given, for example it's A, X, and volume is given, it's Y, but here we do not know concentration and we do not know volume. So through mole concept we can easily find the moles of the A, and then apply the mole concept, and we can easily find the mole of the B, and after finding the mole we can easily find the concentration of B. Is that clear? So in this way we can also calculate titration related questions by applying the mole concept. So a question which is given in your book is that on page number 17, that strontium hydroxide and hydrochloric acid react together, as a result strontium chloride, which is a salt, and water is formed. So the equation is balanced chemical equation. Okay, balanced chemical equation is given for you, and the volume here, volume of the strontium hydroxide is 25 centimeter cube, and that of volume of hydrochloric acid is 15 centimeter cube. So all the volume is given centimeter cube. You have to first of all convert them into diameter cube, and mole of hydrochloric acid is given for you. So let me write the equation again for you, that 2 moles of hydrochloric acid and strontium chloride plus water. Here volume is only given, that is 25 centimeter cube. Okay, if we convert 25 into diameter cube, we will get 0.025 diameter cube. But here concentration is not given. They ask about concentration of strontium hydroxide. We will put them as X. Okay, we also don't know the moles. Okay, why? Because for calculating concentration we have to find the moles, and we also don't know the moles, so I will put the value as Y. Okay, here the volume is given, that is 15 centimeter cube, and if we convert them into centimeter cube, it will be 0.015 diameter cube. Is that clear? In the same case, the concentration of hydrochloric acid is given. Okay, that is 0.1 mole per diameter cube. Okay, but moles are not given. Okay, so how can we find moles? We can find the moles of HCl, moles of HCl. It will be equal to its concentration or molarity multiplied by its volume. So concentration given the question is 0.1 multiplied by 0.015, that becomes 0.0015 moles. Or if I want to write this in standard form, I will write 1.5 into 10 raised to power 1, 2, 3 into 10 raised to power 2, 3 minus 3 moles. Is that clear? So moles are now 0.0015. Okay, so applying the we will apply the mole concept. Okay, applying the mole concept for stoichiometry. Here what will happen, that mole of strontium hydroxide divided by its stoichiometric coefficient, that is here it is 1. The stoichiometric coefficient is 1, and that is equal to here the mole of HCl divided by stoichiometric coefficient. Is that clear? So moving ahead, what will we do? We will mole of we will put them as x because we do not know, and here stoichiometric coefficient is 1. That mole of hydrochloric acid is 0.0015 divided by, and its stoichiometric coefficient is 2. So x is equal to 0.0015. Again it will get divided by 2. We will get somehow we will get 7.5 into 10 raised to power minus 4 moles of strontium hydroxide. This X is strontium hydroxide. Is that clear? So moles of strontium hydroxide, now we find it. After that, what we need to do, we have to find the concentration or molarity of this compound. So definitely simple, very simple formula. We will add the formula of concentration, which is equal to moles divided by volume. Moles are given, that is 7.5 into 10 raised to power minus 4 divided by its volume. The volume is 0.025. So we will divide the value by 0.025. It comes out to be concentration of strontium hydroxide is 0.03 mole per diameter cube. So in the same question, in the same part, they ask you that sodium reaction is given, balanced chemical reaction is given between acid and base. Sodium hydroxide, 2 mole of sodium hydroxide react with 1 mole of sulfuric acid. As a result, sodium sulfate and water will form 2 mole of water. So the values, the related values of volume of 20 centimeter cube volume of sodium hydroxide is given, and concentration, which is, I mention it as capital later because molarity and concentration are the same terms. So we have to find the mole in this equation. Related to sulfuric acid, only volume is given, no molarity and no moles. So first, logically, we have to work out the moles of the sodium hydroxide. So definitely, moles of sodium hydroxide would become equal to its molarity will get multiplied by its volume. So molarity is 0.4 multiplied by 20 centimeter cube divided by 1000. So in the same way, 0.4 multiplied by 0.02. So again, it will become the 0.4 multiplied by 0.02. So it comes out to be 0.008 or 8 into 10 raised to power minus 3 moles. You can also write them in standard form. So in the second step, what you need to know is that you have to find the you have to apply the mole concept. You have to apply the mole concept. So what you need to do, you have to compare the moles from the equation. So mole of sodium hydroxide is equal to divided by stoichiometric coefficient is equal to moles of sulfuric acid divided by its stoichiometric coefficient. So here again, mole of sodium hydroxide is 8 into 10 raised to power minus 3 divided by its stoichiometric coefficient is 2 and is equal to mole of sulfuric acid, which is unknown. Stoichiometric coefficient is 1. So X would become 1 4 to 4. So 4 into 10 raised to power minus 3 moles of sulfuric acid. We have achieved, we got the moles of sulfuric acid. Now definitely we can find the concentration of sulfuric acid very easily, and that is moles divided its volume. Moles are given, that is 4 multiplied by 10 raised to power minus 3, and given volume is 25.25 centimeter cube. Definitely we will divide them with 1000. So this 1000 will go upside. As a result, so it is equal to 4 into 10 raised to power minus 3 multiplied by 1000 divided by 25.25. So we can also write them as 10 raised to power minus 3 multiplied by 10 raised to plus 3, 25.25. So these two values will get cancelled. As a result, 4 will divide by 25.25. So we will get the concentration of sulfuric acid as 0.15 mole diameter cube. So this is m of sulfuric acid, concentration of sulfuric acid. In this way you can calculate all the concentrations and mole of the acid and or base. Now a very interesting question in your course book, especially workbook, on page number 6, that a sample of malic acid is given for you, and this was dissolved in 20 centimeter cube of distilled water. The solution was titrated against 0.125 mole diameter cube aqueous sodium hydroxide. Party asked that describe how you would carry out the titration. Simply we carry out titration through using burette pipette and through using any indicator like methyl orange, like phenolphthalein, and we also use suitable amount of this sodium hydroxide and this malic acid. In the same way, we will titrate it one of these compound against one in each other, and we will find the concentration. So part B of this equation, part B, the equation is given for you, and you have to calculate the volume of sodium hydroxide used. So you need to calculate the volume of sodium hydroxide. For this purpose, what we need to do in the first step, what is required, gram of or weight of sodium this malic acid is given, and you have to convert weight in gram of this malic acid into its mole. So moles of C2H4O COOH malic acid is equal to its weight divided by molar mass, and weight is given, that is almost malic acid, that is given, where is weight of, okay, weight 3 gram, 3.6 gram. I didn't write it over here, but in your book it is given 3.6 gram. So molar mass. Now let's count number of carbon. 2, 3 carbon atoms multiplied by its molar atomic mass plus hydrogen. There are how many hydrogen? 4 over here, 2 over here. 4 plus 2, 6, and oxygen, 3 oxygen. So 3.6 divided by 12 multiplied by 3 plus 3 multiplied by 6 plus 6, we will get 90. So this is the mass of the malic acid. Now 3.6 divided by 90 comes out to be 0.04 moles. Okay, so we find the moles of this compound, but we don't know the moles of sodium hydroxide. So what will we do? We definitely apply stoichiometric. We definitely apply stoichiometry or mole concept. And that is mole of malic acid divided by its stoichiometric coefficient, and is equal to mole of sodium hydroxide divided by stoichiometric coefficient. So moles of malic acid, which are given 0.04 divided by 1, and mole of sodium hydroxide X, stoichiometric coefficient is 2. So moles of sodium hydroxide would become equal to 2 multiplied by 0.04. It comes out to be 0.08. So 0.08 is the mole of sodium hydroxide. Now here that they says that we have to calculate the volume of sodium hydroxide used. We need to calculate the volume of sodium hydroxide. So a concentration of sodium hydroxide as given in the book is 0.125 mole diameter cube. So volume is very easy. We know that concentration is equal to moles over volume. So volume would become mole divided by concentration. So moles is equal to, volume is equal to 0.08 divided by concentration value 0.125, and it comes out to be 0.125. So volume of sodium hydroxide used is 0.64. 0.64. So this is the volume of sodium hydroxide that we have achieved. So I hope that you have understood the concept related to the stoichiometry and titration, and how to calculate the volume, moles, and molarity or concentration. Basically, molarity and concentration is very important and related to the this mole. So I hope that you have understood the concept.